Hey Algebra guys, we are here for our second video on Algebra Tiles. So this one's going to introduce the expression mats. We're going to deal with the negatives, simplifying expressions, lots of stuff here. So first off, let's start off with, you've probably noticed this already, but an algebra tile has two different sides to it. And this is our Y tile. Notice that's purple on one side, red on the other side. Red is forever negative. Every type of tile, whenever you get to red, you're negative. Notice that your Y squared tile is also purple. So purple is positive Y stuff. Red is forever negative. X tiles use blue. There's your x, here's your x squared. Again, red is forever negative. And of course constants. Blue one side, red is forever negative. And green and red is forever negative for your xy. So one side of these is a different color, and the whole point of that is so you can kind of distinguish the tiles a little more readily. You don't have to look at the size of the tile to figure out who is what. But the key concept here is red tiles are always, always, always going to be negative tiles for us. Now, what I'm placing these on here is an expression mat. The expression mat has two regions, positive and negative. You can think of the expression mat almost as brackets. So I have plus whatever here minus whatever is here. Okay? Plus this region minus this region. So you're basically distributing a -1 to everything in here. So for instance, if I replace a positive x tile in the positive region, positive y tile, positive y tile in the positive region, then this is a positive y. But if I brought the positive y into the negative region, a negative times a positive makes a negative tile. Okay. So you're basically just multiplying through by a -1. Now, a big concept here for you is this. It seems pretty easy at first, but it's huge. X minus x is 0. X minus x is 0. If I add 0 to something, I have that something still. So if I added 0, say I had 1, I add 0 to it, I still have 1. If I added a different 0 to it, I still have 1. Now that's a huge concept. That's pretty big. There's a property for that. The zero property of addition. It's the identity property of addition, basically. Anything plus 0 is itself. It's really a big, big concept in mathematics if you think about it. We can illustrate here with little tiles. But for the most part, what we're doing with these is we're going to combine like terms. So how we do that, say we have a nice jumbled mass algebra tiles up here, and let's throw some algebra tiles down there as well. The first thing you want to do is you want to go to each region and you want to look for zeros. You want to pull those off. So up here, let's say I have an x and a negative x. So that forms a 0 pair. Okay? I can take these off. They're gone. Down here I have a -1 and a +1. Forms a zero pair. It's gone. And now I've simplified my expression as much as I can. So what I need to do is distribute this negative. That's my second step. So if I distribute the negative, I'm going to flip these up into the positive region. Now it's a little bit easier for me to combine like terms. I don't see any more zero pairs in this one. What I do see is an x squared minus 2x plus 3. Let's try another problem. We do lots of these. These are actually kind of fun, also, when you start getting into them. Alright, so here's my new expression. Again, same process to start out with. I'm going to look for zero pairs. I'm going to simplify those first. So, right here I've got a -y and a +y. These guys combine, they go away. -x, +x, go away. Nothing more I can simplify up on the top. Let's look at the bottom. There's nothing I can simplify down there. Okay, we got 2 positive y's, 2 positive x's, and a +2. But if I flip this up, remember I'm distributing the negative to all those, so I changed their colors. I now have a positive y and a negative y. I can make pairs out of these ones. -1, +1, -1, +1. And I'm left with my answer, which is -y minus 2 x's. Okay? Let's see here. Build a nice complicated one. Put some ones in there. And you're just playing the same game. So we're like, look in here. We have a y or x squared and a negative x squared. Gone. A y and a negative y. Gone. A 1 and a -1. Gone. Left with an x up top right now. Go to the bottom. -1, +1, gone. -x, +x, gone. -y, +y, gone. Alright, now let's distribute our negative. So negative times that makes a negative. Negative times that makes a negative. Negative x, positive x go away. And the answer is -1. So, really complicated math problem for a Saturday morning turns into playing around with little pieces of plastic. It becomes a lot simpler. And the answer ends up being just -1 out of all that complicated mess that we were able to look at. And that's really the cool thing about Algebra Tiles for now. Later on, I think chapter 6 or 7, you'll see that you can use these same tiles to factor trinomials, and that is really huge. Very powerful, very awesome concept that you can do with these algebra tiles. So these aren't really leaving us, so you really want to try to embrace them, try to understand them, figure out what they are. I'm here to help. Hopefully these videos are clarifying a little bit so you can watch it over and over again, get a good grasp of things, and come see me if you need more help. And if you like these videos, I will keep making more of them so we can figure this out together, okay? So hopefully this has been useful to you, and I'll see you in class on Monday.